Session 3. In this session, we'll look at how SD-WAN is changing the dynamics of routing by using application awareness. Subsequently, we will discuss two important features of application-aware routing known as replication and forward error correction, or FEC. Before we discuss application-aware routing, let's review how traditional routing works. In traditional IP networks, the delivery of IP packets over a WAN access circuit is dependent on IP routing state. Administrators take control of the network by deploying multiple circuits. In the example, the circuit through provider 1 is the primary circuit, and the circuit through network provider 2 is a backup circuit. The design is often called an active backup design. In this configuration, the backup circuit remains idle most of the time and is only used when the primary circuit fails. The other design choice is to use both of the links by leveraging equal cost multipath or ECMP routing. This is called an active-active environment, and traffic from branches can be load balanced across all available links. In either case, when a circuit experiences poor performance, or events such as brownouts occur, moving business-critical traffic to an alternate WAN poses significant challenges to administrators. Handling such events are always manual, time-consuming, and prone to errors. Application-aware routing helps organizations mitigate these issues. Application-aware routing is a paradigm shift when it comes to routing data packets through IP networks. Application-aware routing is implemented by using SD-WAN policies. With application-aware routing, administrators can assign traffic to a WAN circuit based on the application, not just routing state. This allows administrators to apply much granular control to steer traffic over available LAN links based on the link properties and performance, and based on the application needs. How does application-aware routing differ from traditional routing? A traditional branch router performs routing based on layer 3 information. To be more specific, it's based on the destination IP address present in the IP header of the data packet. Some implementations allow a CPE to make a forwarding decision based on layer 4 information, such as protocol and port number. Application-aware routing capability allows a CPE to make forwarding decisions based on layer 7 information, also known as application layer information, which is present in a data packet. This allows a branch CPE to be aware of various application streams present in the network. Administrators can then apply business-specific policies to those streams. A simple example would be preferential treatment to business-critical traffic such as Office 365 traffic over non-critical traffic such as Facebook or YouTube traffic. Application-aware routing capability in an SD-WAN solution can give much greater control to an organization for routing traffic over WAN circuits. Along with this, SD-WAN also provides much deeper visibility into the performance of WAN links. This visibility is not specific to the last mile of the WAN connection, but end-to-end between any pair of sites. Such detailed visibility is achieved using SLA probes. The probes can reveal even a minor fault in a circuit and provide end-to-end visibility. Network nodes can be made aware not only of latency, jitter, or packet loss on a specific circuit, but also the direction of packet loss. Information such as forward packet loss or reverse packet loss, transmit load, received load on any WAN link, and many more properties of the link can be measured. Advanced metrics such as MOS measurement can reveal which WAN circuit is performing better for real-time voice or video streams. With application-aware routing capabilities and deeper visibility into the network, administrators can program branch nodes consistently in accordance to the organization's business needs. Consider a solution that allows administrators to identify 3,000 or more applications and provides constant visibility into the network. Now handling negative events and brownouts becomes automatic. The moment a negative event or brownout reaches a programmed threshold, an SD-WAN node can take the necessary action to move the data stream to an alternate, better path. The granularity of this programming can be on a per-application basis. The result? No human intervention, no downtime for the application, and not susceptible to any human error. As we discussed, SD-WAN policy has changed the fundamentals of traffic routing from IP-based to application-based, but that's not all. SD-WAN has also made several improvements to application-aware routing capabilities. In this section, we'll look at two more improvements: packet replication and forward error correction, or FEC. Before we discuss replication, let's consider a scenario where the network is required to carry real-time traffic, such as voice or video, between sites. Real-time traffic has strict delay requirements, and in case of a lost packet, retransmission is not an option. The customer experience can become very poor in such cases. Packet replication can help in such situations. In a very simplistic form, packet replication enables creating a copy of each packet at the ingress to the WAN. A copy of the packet is sent over each available WAN link. An SD-WAN node does two things when packet replication is enabled. First, it makes copies of the original packets and sends a copy over all the available paths to the destination. Second, the remote SD-WAN node discards duplicate packets and sends only one copy to the end recipient. Of course, this results in higher bandwidth utilization and therefore may not be a good solution for all traffic or in all scenarios. A smart SD-WAN solution doesn't just provide replication capabilities, but can also provide greater control over replication. Versus SD-WAN solution provides that control. Remember the two capabilities discussed earlier? The visibility of link behavior using smart SLAs and the ability to identify applications? These two capabilities allow replication to work more efficiently. This visibility allows replication to start only when link performance drops below a programmed threshold and to stop when a programmed acceptable threshold is breached. At the same time, application awareness allows the administrator to select which types of traffic are replicated based on the application type. The result is that the replication feature becomes smart and only starts when it's necessary and stops when it's not needed. While replication is in effect, if a packet is lost during transit, the lost packet is identified by the receiving SD-WAN node and the data stream is reconstructed by using the copy received from another link. The receiving SD-WAN node also takes care of reordering the packets if required before data is forwarded to the recipient. Like replication, forward error correction, or FEC, enables the recovery of lost or corrupted packets by regenerating them using special packets called parity packets. This reduces retransmission efforts by end nodes. With this technique, a special packet known as a parity packet, or FEC packet, is generated in the data stream. By default, a parity packet is generated for every 4 packets transmitted, but administrators can define less or more aggressive generation of parity packets. The receiving node can regenerate a lost packet using the FEC packet, so that the end station doesn't require a retransmission of the lost packet. FEC can be enabled for nodes that connect using single links as well as multi-homed nodes. Like with packet replication, FEC can be triggered only when necessary. Administrators can also choose to replicate just FEC packets over multiple links. With packet replication and forward error correction, administrators can have better control over the user experience even when links are experiencing problems in the WAN. This is the end of Session 3 of the Versa Essentials series. In this session, we discussed traditional routing versus application routing, packet replication, and forward error correction, or FEC. Thank you for your participation in this session. We hope you found the session informative. In the next module, we'll discuss direct internet access.